Howdy! My name is Kendall, and my partner Kelly and I are going to demonstrate the Color Crawlers project. We want to see if colors can crawl from one cup of colored water to another with only a paper towel connecting them. As you continue watching, you will see a breakdown of the materials used, a setup of the project, the process as it occurs, the background on the science that occurs during the project, a breakdown of the experiment itself, our experiences through the project, and a time to ask questions at the end.
So I'm going to demonstrate the Crawling Colors project for y'all and how to do it with your class. So we have 6 clear cups. In this case, these are just plastic disposable ones. You can use many different types. We use glass ones in our actual project. Glass can be sturdier to hold the paper towels from falling over, but this is how you can also do it. And you can do it with mason jars, anything you want. So you're going to take 6 cups and fill up every other one halfway with water. If you want to fill it up more, just keep it even with all of the other ones to make sure that one doesn't have more water than the other. And then the cups in between the filled cups will be empty. So your next step is you're going to take your colors. So we're going to be using primary colors, in this case red, yellow, and blue. And so you are going to drop in some food dye. I'm using gel food dye. If you use normal liquid food dye, it takes about 20 drops. In this case, you can do it with like 1 to 2. So just drop it in and you'll see with red first, because it is the first color of the rainbow. And that will turn the water red. There we go. And then you'll next use your yellow food dye and drop that in and mix it up. Make sure that the water that you've put in these cups are the same temperature as each other so you can get an accurate measurement on how fast the water can go up and over the towels. Last one is blue. And put your blue food dye in. Mix it up. So now you have your primary colors that we're using for this Crawling Colors project. Next, and pretty much our final step for preparation is to put in the paper towels. So we're going to have our paper towels like this. We are using half sheets of paper towels, the paper towels that aren't the full width, and you are going to take them and fold them once and then over again. So they will look long and thin. And so you are going to take 6 of these. I found that during the actual project, it was better to double them up and use 2 of these from cup to cup, but it works great this way too. So you're going to take a paper towel and go in the cup of color and in an empty cup, and then do the same all around. And then you'll wait. It'll take about an hour or 2.
During this experiment, there are 3 concepts that come into play. The first is physical changes, then mixtures, and the last is the idea of capillary action. First, a physical change. A physical change is defined as a change where no new substance is formed. The only thing that is changing is the physical components. Some examples of this can include a change of shape, a color change, or a change of texture. There are many examples of physical changes that you've seen in your life, but let's name just a few. The first is melting an ice cube. The composition of what makes up the ice cube stays the same. It's now just a liquid instead of a solid. The second example is the shredding of a piece of paper. The paper remains paper. It now just looks different as it's in smaller pieces than it was before. The next science concept that we need to understand is the concept of a mixture. A mixture is a physical combination of two or more substances, components, or parts. You can make a mixture of many different things. For example, trail mix is a mixture. It's a combination of individual snacks brought together to make a new food. The sand in the sandbox is also a mixture, and if you make lemonade, that's a mixture as well, as the lemon, sugar, and water combine to make a new drink. There are multiple different types of mixtures, specifically heterogeneous and homogeneous mixtures, but for our project, we need to know what a homogeneous mixture is. A homogeneous mixture is defined as a mixture with a change of characteristics of the parts that make up the mixture to make a new substance called a solution. The mixture can't be separated, meaning that once you mix it, it stays mixed. Some examples of homogeneous mixtures are water, as it has lots of minerals that can't be taken out of it, 2, a concrete or cement, or 3, the laundry detergent, as it's made of many different soaps and chemicals. Lastly, we have the idea of capillary action. Capillary action is the concept that water moves upwards against gravity. This concept is most commonly identified in plants when water moves up the roots to nourish the plant. But in this case, we're using it as the colored water moves up the paper towel fibers into the next cup. Paper towels are great for this experiment because their absorbency allows this process to happen.
So as time went on, we see that the colors eventually crawl up and around on the paper towels. So this is the vision of capillary action, where the water in the primary cups climbs up over the paper towels and deposits in the empty cups. But with paper towels sticking out from each color and into each empty cup, it'll form secondary colors and creating a full pinwheel of full colors. So this will end up looking like a rainbow. And my experience with this, it was difficult, honestly, to have the filming of it. It took a bit longer than I expected. And to speed up the process, I did 2 paper towels, like I mentioned, and I just doubled them up, kind of like so, in each cup. So there was essentially 12 paper towels now in the project. And this just helped the water speed up, and there's double the amount of water going through the paper towels, emptying into the cups. It also was a little bit difficult to see the colors, the secondary colors in here, until I took out the paper towels. We'll insert a picture for you of the after product. But it was really cool to see that immediately when you put the paper towels in, capillary action starts happening, and you get to see the results for your students. And so this would be something that would be maybe difficult to do during just a period of middle school, but it would be easier in an elementary situation where you could have a longer period of time to look over of what the paper towels end up doing.
All of my experiences throughout the project were very positive. Our expectations for how the experiment would perform rang true, and we were able to see the 3 scientific processes really come to life. The experiment was easy to conduct as a whole, and I believe it has the potential to be an effective teaching method as it will be implemented into lower elementary school classrooms. I was welcomed with great support by my partner, and with her help, our presentation was seamless and smooth. At this time, we would usually open up the floor for questions about our demonstration. As we are conducting this presentation virtually, please feel free to reach out at the email on the screen with any questions you may have. Please stay safe. Thanks, and gig 'em.